All right, yes, this talk is about DNSControl. It's the system we made to manage our DNS at StackOverflow. My name's Craig. Tom is here with me. He's my manager and the co-author of this system. My name is Craig. I am a developer on the SRE team at StackOverflow. I'm not a sysadmin or an SRE. By trade, I've kind of been adopted into this world, and it's been a really fun ride learning this stuff. I really like it a lot. In this talk, we're going to talk a little bit about why DNS management is hard, some of the pitfalls and problems with the ways we have done things in the past and how a lot of people manage them. We're going to show off the system we made to make it better. We're going to show off some of the cool things we can do with it and the applications. And then we're going to talk about what it is, how we built it, and how you can use it too. So I think it's a pretty common viewpoint that DNS management is hard. A lot of people really don't like it, and for a variety of reasons. At Stack Overflow, we do DNS management at a pretty large scale. We have a lot of domains because we have a lot of Q&A sites, both from Stack Overflow to Server Fault for sysadmin things to philosophy and cooking and math. You name it, we have a site for it. So between all these sites, we have thousands of DNS records we manage. In our DNS, we've hosted it ourselves with Bind, but currently we're running on multiple cloud providers that host our DNS, as well as our own on-premise things, Active Directory for internal things, a lot of different DNS systems in play, and our infrastructure is in multiple places as well. We have 2 data centers that run most of our infrastructure and various apps and tools in the cloud that we use as well. So we have DNS in a lot of places, pointing at a lot of places, and we change things a lot because we like to. So how do we do DNS? Historically, we've been this guy. We've been the lonely monk scrawling out our artisanal, handcrafted zone files. Is anyone here still manually editing zone files? Cool. There's nothing wrong with this. It's a standard zone format. It's invented in the 80s. You write down your records, the types, the content, the TTLs, the names. It's pretty straightforward if you know what you're looking at, which I rarely do. But it's text. You can manage it. You can see we have it in Git. It's fairly easy to add a record. You add the line. You got to be careful. The serial number has to increment. It has to be increasing over time or changes won't get picked up properly. But that's not a big deal. You can do that. You can manage these. What's the problem with this? It's fine. It works. But first off, manual change is something we don't like. If you consider something as simple as an A record for stackoverflow.com, it points at 198.252.206.16. Which you probably recognize as our primary New York load balancer. But we have 2 data centers. If we want to fail over to Colorado, it's a simple change. You just rewrite it to our Colorado IP address. That's no big deal. Remember, we have a guy for that. We can write our zone file. But if you remember, I said we have 1,000 or more records. And so how do we rewrite 1,000 records to fail over? You can keep hiring more guys, or you can write scripts, get more monks in there. But that doesn't scale really at all. And you can break things real easy. If you miscopy one IP address, you're pointing at the wrong thing, serving who knows what. Even worse, if you fat finger in the wrong way, bind will not start because of a bad zone file, and you'll have an incident, and you'll be debugging it in chat. And this has happened to us. So I don't think it's really a stretch in this room to say that manual change is something we don't like. I think you get that. But it doesn't even really matter because we can't go on in this way because we decided we want a lot of these features that these cloud providers have. They have massive DNS networks with Anycast, magic things that they do. Google Cloud or Route 53, they can provide a much better DNS service to our Australian users, to the whole world, to do a better product. But they don't let us give them zone files. They all have a different way of managing DNS. And for all of them, they have these web panels where you click and you type one record at a time. And they're all bad. This is CloudFlare's, but everyone has one, and they're all different. We've used all of these products, and they're no fun at all, for a variety of reasons. I think the web panel is really the antithesis of a lot of the values we have as SREs. They lock you into one provider. You can never export or import, or if you can, it's never going to be compatible with anything else. So you're stuck on this provider, or you're stuck copying and pasting. There's no history, there's no audit, so if you want to know what it looked like at a point in time, you can't do a postmortem on what your DNS was. You don't know why a record's here, or who wants this, or do we still need this? Who knows? So it's very clear very quickly that the web panels are a no-go. We're not using that, but we still want to use the cloud. Luckily, they all have APIs, which is good, but they all have different APIs. So how do we get there? How do we maintain our bind server that we still want and these cloud services and not have script soup and a lot of duplication? Well, this is a real problem. So we made a system to solve this problem, and we call it DNSControl. It's a system we wrote. We think of it as a language and a compiler for DNS specifications. Those are words. I prefer the picture of what it looks like or what it does. I think of it as we have our DNS config as a single file, our source code for our DNS. We feed it into our application. We can call that the compiler. It will read our configuration and decide what records we need and build kind of our canonical list of what records we want to have, our intermediate representation. And from there, it pushes it out to all the different backends that we want to use. We are currently in production using 6 different DNS backends for various parts of our infrastructure. And from the single file, DNSControl can push to all of them quite seamlessly, actually. This is a pretty high-level diagram. There's probably a lot of questions. First off, what does that configuration look like? Well, it looks like code. Here we have a snippet from our zone for StackOverflow.com. You see the D function is a way to define a domain. We have a bunch of these in one file. And here we specify that StackOverflow.com is registered with our name.com provider, and DNS is provided by Google Cloud DNS. And then we add records to it. We have A records with IP addresses, C names that point to other domains. And it's very important to us that this is not a toy language. This is not a subset of DNS. This is actually our full DNS configuration. So we can set TTLs in here. If there's any aspect of the records that we need to modify, we can do that with this DSL. It's very important to us that this does everything. So we take this source code, we feed it into our app. Do the edges show enough? So we first will run DNSControl preview locally. And here I'm running this command for the domain bosun.org, which is a documentation site for our monitoring product. And here you see that it's running our bind provider, and it says, OK, I need to regenerate a zone file to add this record. And then it's running against CloudFlare. It's saying I need to create this A record in CloudFlare via the API. It's gone. It's deduced how things are different, and it's decided I need to make these 2 changes. But the preview hasn't done anything yet, which is something we also really like about this, is that we can make changes and see how they will affect things without actually changing anything, which is actually quite valuable. Because if we had messed something up and it said delete everything, that would be a problem. We wouldn't want to proceed. So once we're happy with how it looks, we run DNSControl push, and it does the exact same thing. Goes to CloudFlare and reads the zone files and finds the differences. And this time it actually executed it. So here I've regenerated a zone. I've given that to bind, and I've updated CloudFlare, so it's now serving this new record. It's updated all of that magically, again, from a very simple input file, which I think is pretty amazing. I think it's magic every time I watch it run, because it just does stuff, and the internet starts changing, which is real cool. That's a pretty simple example. The thing I love to think about this is that it is a programming language. And so you can do all kinds of things you can do with programming languages, like use variables. You remember our snippet, one thing I noticed very quickly is that we have 3 different IP addresses here. 2 of them are the same thing, and all 3 of them are in the same subnet. They're very similar. And we don't like duplication. It's bad. So we can very easily define a variable for our base of our subnet, and then reference that base IP everywhere we define a record in that range. And notice that IP addresses are numbers. That's something I learned that I didn't realize before, although it makes perfect sense now. It's just a 32-bit unsigned integer. So we can define the base of our subnet and then do math on it for our individual records. So we know the different offsets for where these servers live. So that's okay. That saved us some copy-paste. But the real cool thing is, remember, we have 2 data centers, and sometimes we switch between them. So we can define variables for each data center's IP range and then have a third variable that selects one of them. So now all of our records reference the base IP, which is pointing to New York. But if we want to failover to Colorado, it's a really simple change. If you watch this transition, that's how we fail over. I like just toggling between these because that one line change will essentially trickle down through every record that references base IP. So we're adding hundreds of IP addresses in these records just by toggling that one variable. And this is something that has really opened our eyes to how we want to operate these kind of failovers. And we've been able to do it on a much more granular level than we could have otherwise. With this IP trick and another little trick, because our servers are named consistently, which I hope most of you have some kind of system, right? We have a service in Colorado and in New York, and we name it thing CO and thing NY. So it's pretty simple to say, where is the thing as a variable, and use a string, and then we can just concatenate thing CO or thing NY to generate our actual record for a CNAME. And so we can switch things. And this kind of strategy has led to our DNS file really having a playbook embedded in it at the top, where we have a list of here's all the different things we can move around, and here's a description of it in the code. And we're not just going to tell you how to do it. We're going to actually put the code in there, comment it out. So if there's an emergency and we need to fail over the VPN or chat or Git or whatever, right? It's not just read the docs and make a change. It's here, we made the change, just uncomment it. So we're trying to make it as idiot-proof as possible, as easy for an SRE to make a change as we possibly can. And so this set of variables allows us to do very high-level changes with very small actual changes, which has made it very easy for our SREs to know how to make these kind of DNS changes. Another thing we've done with this that we really like is what we call macros. The best example of this is the Google Apps MX records. If you want to use Gmail or Google Docs or anything, there's a bunch of records you got to add. There's 5 of them. They're all very similar. They have changed in the past. Who knows what the future holds? We definitely don't want to copy these into every domain. So we can define it as a variable as an array of records, and we can just reference that variable in each domain we have that needs these features. And now they all magically have these 5 records. So that's a really good way to, again, avoid copy-paste. We've used this for like common domain settings, TTLs, common providers, any number of things that are common to a bunch of domains, we can put in a central place to include in multiple domains, which is quite valuable. The other thing we've realized we can use is code things like loops and if statements. Does anyone else have the problem I do where at 2 a.m. you'll buy random domain names you think are funny? I have like 20 in my various accounts, that maybe I had an idea, maybe I just thought it was a funny joke, but like I have a bunch of domains I'm probably never going to use, but I just want to kind of make sure that I keep owning them until I choose not to. Maybe point it at a landing page. Tom showed me this trick. You can actually just make an array and then loop over it and apply some common config. You can't do that with a config file or a JSON or anything, but you can write code to do whatever you need to do, which is really nice. All these code features are kind of neat, but really what's important is the applications we can do with it. I think the most important thing that this has given us is the freedom to change DNS providers, which is a scary thing to do. It's very risky. I think there are real-life boulders that will kill you, and it's not something we really have looked forward to. But we've done it 4 times in the last year, like it's nothing. We don't feel locked into any provider at all because it's very easy to change who's hosting your DNS. If we're on Google Cloud and we want to switch, it's as easy as changing the provider that's servicing it in your domain definition. And there's a lot that goes into changing that. You have to do quite a bit. We sync the records to Route 53, so they're consistent with what they were in Google Cloud. We update the NS records. We have to give those to the registrar, who gives them to the .com name servers to serve. There's quite a few steps, but our system does all that for you. Again, you change one line of code and recompile, rerun it, and your config goes everywhere. I don't know if we changed providers. We, like a lot of people, kind of woke up with the dying outage this last year. Our colleague Mark wrote a really cool blog post. He did a lot of research. The link is there. You can read it if you like. It's quite good. But we've gone to a dual provider setup so that rather than just having one provider hosting our DNS that can get DDoSed or can disappear, we're syncing all of our records to 2 providers. Right now we're running with Google Cloud and Route 53. And both of those are authoritative name servers. Both of those get all of the records synced. Anytime we change a record, it goes to both of them. The registrar points at a combination of their name servers. So with a one-line change, we go from single provider, we can go down, if that goes down, to no single point of failure. If everything works as it should, if one of those gets DDoSed, the internet just fixes it. Resolvers will go to the one that's still giving responses. If there's an extended outage, we have the same power to switch away, though. If we need to go to just one provider for a time or activate our on-prem bind server if we need to, we can switch on the fly to whatever we need to do. And it's really nice to have that card in our pocket that we can not be afraid to change. We can test this ahead of time to make sure it's ready to go if we need it. I think it really removes a lot of fear from our administrators. We also found that as our traffic patterns got more complex, we had more different things we needed to do, like a CDN. When we're running without our CDN, we will have a single A record that points at our load balancer in our data center. But if we're running behind our CDN, then they have 4 different IP addresses that they want us to use for resiliency or what have you. But it was kind of tricky to realize, well, we want 1 record in some situations, but 4 records in another one, and there's 100 places where we would need to change this to toggle that. How do we do that? So we came up with a system where, well, we can apply rules to records. And we're going to always put our data center IP address in records. And if we need something different than that, we will apply rules to it. So here we have it looks scary. It's a very simple transform rule set. Say IP addresses in this range get replaced with this set of IPs. IP addresses in this range gets replaced with this set of IPs. And then we can define 2 variables, right? Fastly on, fastly off for our CDN, where we either apply that transform or don't. So on a record-by-record level, we can turn our CDN on and off. And if we apply that fastly on macro, right, every record that has that gets transformed into 4 or not, depending on what you do. So again, we really love making big changes with small changes. We're trying to make DNS more boring and less tricky. And I think this accomplishes that goal. This technology, the transforms, have done any number of things. We've used it for internal IP switching for internal services to not go out over the internet. Other CDNs have slightly different transform patterns. But it's as simple as define the rules that you want it to do in certain situations and let our app transform it for you when that applies. There's also a lot of features that are not strictly DNS with various providers. CloudFlare has this orange cloud that determines if they're proxying you or not. And that's not driven by your DNS records. It's an extra feature they have on their website or in their API. And so we did make a way that we can drive that with our DNS config by providing some extra metadata fields with records. And that allowed us to manage that feature, even though it's not like DNS. But there are other features in that scope that we can manage. We haven't done it yet, but I could easily see this kind of style going for managing like geo-routing for these providers that support it. If you're in a situation that uses that, which we aren't at present. But any other features these providers have, there's other ideas for things kind of related to your domains. We can do a lot of stuff. That's all I'm saying. So how is this implemented? It is a Go app that we wrote. It's not a ton of code. 6,000 lines is some. This is kind of the culmination. Tom has said everywhere he goes, he writes some version of this, and it's gone from Bash to... we were using a Python app that did this. We ported to Go for a variety of reasons. We really like having static types and especially a single binary we can deploy. So we can give each of our SREs, we have a single repo that has all of our DNS-related things in it. It has our config file, DNSconfig.js, has all the credentials for our cloud accounts encrypted. That'll be important later. But it's not just plain text in our repo. That would be bad. We also put the binaries in there because we have SREs that all have different preferences for what system they go. We have Windows and Linux and Macs. And because Go gives us good static binaries, they can just run this. They don't need to have Python installed in their box. They don't have to have the libraries installed, which all have native extensions and cause problems. But here they just clone this repo and they have everything they need in an emergency to change all of the DNS, which is very valuable to us if they need it in an emergency. And why do we use JavaScript for this language? A variety of reasons. Mainly because we didn't want to write our own language. That seemed out of scope for this. We've done that. Parsers are hard. It's kind of fun to make your own thing, but we didn't want that work. So we found a Go implementation of JavaScript, which sounds super scary, but it is tested against a spec. It's the full JavaScript language, and it works. We don't have to maintain a language. But the front-end DSL is actually less significant than it seems, even though it's how we input our records. All of that code I've showed, just those functions, D and A and so forth, they just build a data structure that becomes our canonical DNS config. We call that the IR, or the intermediate representation, to steal a compiler term. And that's what's really important. We learned this kind of the hard way over time. We needed something more complicated than a JSON file because we have variables and loops and so forth. But it's very hard to test if you just write a programming language that executes things. And so it's actually really useful to have this object model generated by your input code. And that turned out to be really valuable when we were porting from Python to Go because we could just dump that part and make sure it was exactly the same. So it was a much cleaner port as we went. In addition, that makes our providers have a really easy job. So rather than having each back-end provider have to know about the code you're inputting to this system, A provider implements a very simple interface that says, I have a list of records, I want it to look like this, make it so. So it's actually really easy to code against because we have kind of this intermediate level object graph that we can normalize and fix up and then hand off to the people who actually do stuff, which is really nice. We really wanted to have a modular design here so that nothing in this system is just for Stack Overflow as much as possible. If there's anything we do that is specific to a single provider or specific to only we will ever use this, we try not to make it a part of this system. Like those transforms I showed you, we had various iterations of an idea like that that was very hard-coded and very brittle, not very useful, until we kept adding more ways to do it and realized if you just make a simple rule set evaluation system, it's useful to a lot of stuff. So our hope is really that if you do weird things with DNS, which is cool, I'd love to hear what kind of oddities you have. I'd hope that our system can accommodate you as is, or we can certainly make a way to make it work in a general way if it doesn't. That's kind of a core part of our philosophy. Additionally, this system has given us, I think, a lot more alignment with what we would consider SRE values with how we manage our DNS. We're not doing manual changes anymore. And we've really lowered, I think, the floor of what our SREs have to know about the given providers. If you've used any of these APIs, they all suck, and they all suck differently. Some of them want records in one format, and some want it in another. If you give it in the wrong format, you'll get like stackoverflow.com.stackoverflow.com records. And there's a lot of ways to shoot yourself in the foot with these. But what we've done is our DSL only accepts one way to take records. If you're given an A record, it has to be a valid IP address. If you're given a C name, it has to be a fully qualified domain name with a dot at the end, and that's that. And if you don't give us that, we're not going to take it. So there's one way to define your code, and it's up to each provider implementation to fix it, to make it work with how that API wants it, or to handle the quirks, which there are many. So our SREs need to know exactly one way to input the DNS, and we do the rest, which makes less knowledge spread around the team, which makes it a lot easier to change. Additionally, all of our code is in Git. It's one text file, and that has given us a lot of organizational benefits because anyone in the company can see our DNS config. People we would never give credentials to update a cloud account, they can see the config. If marketing wants to run a promotion on a domain, they can not only look at it, they can make a pull request to us to make that change themselves. They don't need to bug us in chat. They just make a pull request. Sysadmin can look at it and merge it, and they're good to go. So we have a self-service model without spreading any access that we don't want out there. And that's pretty cool to me. Additionally, we have continuous integration for our DNS. Essentially by convention, we can run preview locally, but then we never run push locally except in an emergency. We commit our code, and the build server takes it and runs it. And that gives us a number of benefits. Number one, we have a central history of when anything changes. We can dig into any one of those to see exactly which records changed. If something goes wrong, we can look at the error. And we can press a button to roll back. If something goes wrong, we don't have to waste time mucking in Git to roll it back. We just press the run button on the previous revision, and it fixes everything. And we don't do anything by hand anymore, which is good. So where are we with this project? We currently have 10 providers implemented, or mostly implemented, both ones that we've used in production and ones that various engineers use personally and just wrote a provider. It's super easy to write a DNS backend. I wrote NS1 in my hotel room last night as I was working on this talk because I talked to those guys and they have a cool product. And it's super fast to write a provider. If you use something not on this list, we can make it happen. You can do it yourself. You can come to us on GitHub, and we can help you through it. It's super easy. And we would love to have more and more providers in the future because that makes us more usable for more people, which is good. We have no end of ideas of what we can do with this. We'd love to do a system where we can just periodically test your records to make sure they're all still good. HTTP redirects is one thing that we don't have managed by this yet, but we would love to if we can get the right APIs. DNSSEC would be great, but again, support in the cloud is kind of spotty at best. Warn you when your domains are going to expire. You name it. It's not hard to find ideas that can integrate with this system once you get going. So if you're interested in trying it out, we have open sourced it as of this morning. It's on github.com. You can look it up, and there it is.
So, great tool. Thank you very much for open sourcing it. So, for those of us with very large domains with like thousands of records per domain, do you guys have a tool to like grab those and create the JavaScript files to start?
So, well, first, if those are things that can be described in the language, the compiler runs very quickly. But I think what you're saying is you have some subdomains that are automatically generated maybe from a database or something?
So I'm more thinking of like, how do I bring my domains under control of the tool?
Oh,
where like I already have like hundreds or thousands of subdomains, and I just want to pull them in to
how do you bootstrap?
Yes.
I have an awesome awk script that will take most zones and turn it into this language, and then a little bit of Vim or Emacs, and you'll be going.
Can you add that to repo?
Yes.
Yeah, if you could.
And then you do DNSControl preview, and you could see where you messed up, because it wasn't my awk script's fault.
You can run it and see that it wants to delete everything, and then transform the deletes into actual records.
Oh, yeah.
We don't have anything built in,
Okay.
but I'd love to think about that some more. It's a good idea.
Cool. Thank you.
Managing 1,200 plus domains, so thank you. I notice you have a lot of providers for serving the DNS. What different registrars do you support?
Right. Again, the registrar is actually an easier piece to implement because you're essentially saying, these are my name servers, make it so. Right now we have as registrars name.com, Namecheap, Gandhi. But again, that's one function to write and a little plugin.
Okay. Yeah, I wasn't sure of who has decent APIs these days and even the ability to do that. So
that's really the trick. Is some of them are much more accessible than others. Some you have to pay money for. Some you have to have X number of domains. It varies, but if they have an API we can get, we can code against it.
Thank you.
Pretty fast.
Hi. Great talk. That's a very interesting tool. So I guess I'm happy that you touched on the CI piece of it. It seemed like that was an important consideration. I had questions early on in the talk about, like your workflow basically becomes, if you need to emergency failover, some human has to check something into Git. I was just wondering, like, if you can kind of describe the thought process to that over using the higher level service, like maybe Route 53, health checks, or something like that, and why you chose that. Thanks.
Sure. Yeah. So, by the way, our definition of an emergency is that our CI system is down, because basically, and that's the only time we've needed to do a manual push. So we do not use AWS for most of Stack Overflow, so we don't use features like their load balancer and stuff. I have a feeling it would be pretty easy to add mechanisms to play well with that, but the short answer is we don't do that. We don't do any of that right now. It should be easy to add.
Hi. Is it possible to skip records in a zone? Like if in a zone like I had some records automatically by the servers, like via the API, is it possible to tell the system to actually skip those records?
We ran into that because we had similar situations. We had automated scripts that were adding and removing things periodically. So there's a couple different mechanisms. You can manually like blacklist, like ignore this record, or we have a mode we run in. It's like a no purge keyword. It just says don't delete anything, just add and maintain things you know about, but leave the other stuff alone. So yeah, we've run into that as well.
All right, good. First question: can you add the awk script to the repo so that when we start putting our own stuff, that becomes super convenient? But the real question is how do you guys track state to know when you're failing over between zones and whatnot?
That's a larger system that's a larger system that this plugs into.
Okay.
Yeah.
I had a quick look at the repo. I see there's no support for PTR for reverse zone generation. Do you guys care about PTR records, or is this not a thing that you?
Funny you should ask that. You're right. Right now we're not generating PTR records because those are a big static file. It would be really easy to add, but we just haven't had the need. Sure. Oh, and actually, so we do have a mechanism that says this zone is generated by calling this function, and usually we pass it the name of another zone, and because we have certain zones that are just like this zone, but a couple transforms, and so to make a PTR zone, I think it's going to be very simple because we'll just use that mechanism, but say the transform is to flip the octets, etc. Yes.
Hi. Do you also support NSD and unbound config files, or the main config file, not the?
You mean bind or
unbound? And
unbound.
Unbound and NSD.
So what we call the bind provider right now, it really just maintains a folder of zone files. So when we actually push to bind, it's as a make file outside of our app.
Yeah, so we'll make standard RFC whatever zone files, and if I may brag, we actually if the file doesn't exist, we just generate the zone file. If it does exist, we read it in and do a diff, so it actually outputs. Even though internally it's just generating a new zone, it'll say this record is added, this one's deleted. So you could actually, it's a pretty good diff.
So the second one is, does the bind macros support it, like include and expand?
We don't do anything with that right now, no.
Thank you.
But again, this whole system has kind of grown organically as we need to make changes. And so we welcome anybody saying we need to support a new thing, because that lets us, I get to learn new stuff because I'm just diving into this, but this can grow.
Hi. I have a question about the DSL. So when you kind of start implementing the DSL, have you considered using the existing tools such as the HashiCorp, Terraform? And if you so, would you mind to share us with the why those existing tools didn't work for you?
We have not integrated with
that
yet. But so you mean why did we invent our own DSL instead of going with something like HashiCorp? Well, even though we're open sourcing this today, this has actually been around for a number of years. Okay. So we were there first.
Sure.
But yeah, so if we were starting today, maybe I'm actually not that familiar with Terraform, but okay. So I don't have a good answer.
Thank you so much.
Sure. Any other questions? Okay. Well, thank you very much.